So in the past, there's been a lot of hype around GraphQL, and I wanted to try and put some of that into perspective. At the end of the day, you want to find the best or most appropriate tool for the job. So the question I'm posing is, do you really need GraphQL? It offers some wonderful features, but as with everything, there's a cost. And that cost could be the learning curve, it could be the running and maintenance overhead, it could be the security or performance. So before you burn your existing APIs or rebuild all your infrastructure from scratch, take a moment to consider how much of GraphQL's functionality will you really use? What was the main draw for you? And this video comes out of the fact that a lot of people out there, when asked why GraphQL, the standard answer is, it's so cool, it stops all that over and under fetching of data, asks for the data I need in the format I want, and GraphQL gives me back exactly what I asked for. And it's only much later that they start to think about mutations, and even further down the line when they discover subscriptions. So I thought, well, let's explore GraphQL's query functionality and what that has to offer. I want this to be a practical exploration, so the way I'm going to tackle this is to go through the graphql.org's documentation on queries. We're going to look at what it offers. There are plenty of examples we can work from. We'll take a RESTful API as our starting point and work systematically to see what changes we would need and how much work it would be for us to add some of the most beneficial features that GraphQL boasts into our existing APIs. In the next segment, I'm going to go through the initial project setup. Feel free to watch or skip to the next section where we start the actual GraphQL exploration. So for this demo, I'm just going to use the serverless framework, and you can just follow the instructions on their website, serverless.com. I have serverless set up globally, so I'm just going to start in the terminal running serverless, and you end up on the setup view, which is going to walk you through the setup. I'm going to be using Node.js, and we'll be creating a REST API, which I will call GraphQL Prototype. You'll see it's starting to download the AWS Node REST API template. This takes a little time, but eventually the project is created, and if you have a login or want to register, then say, yes, I'm not going to for this prototype. I'm also not going to worry about deploying right now, so we'll just test our assumptions locally for this project. So I'm going to say no to that as well for now. And what we end up with is this very simple project. If we open up the serverless YAML file, it just has a single endpoint with a get method linked to a hello handler. And the hello handler just has a simple payload, which is a bit of text and event data. And what I'm going to do is just pause here, go off and create our database and the initial setup so we have a starting point for this demo. And when I come back, I'll go through the changes I've made. Right, I'm back. Let's see what our initial setup looks like. On the left, you'll see our database schema. It's based on the Star Wars episodes and characters, which is what the GraphQL documentation chose for the examples. So I've tried to create a schema so that we can follow through with the docs as closely as possible. It's a very simple schema. We have characters. The hero column in the characters table is a bit of a hack, but I wanted our results to match up with the results in the documentation examples, and they mainly work with a single hero character. Character friends is a straightforward relationship between characters and their friends, of which both are linked back to our characters table. We have episodes, each of which has a hero, which again links back to our characters, and the episode characters allow us to create an association between our characters and the episodes they're starring. Added to the code, we now have a package.json file. The packages I've added are Sequelize as our ORM for our Postgres database. Sequelize Auto is really helpful if you have an existing database because it automates the model creation. Serverless Offline is so we can run our lambdas locally. Then we have TypeScript and the serverless plugin for TypeScript, and PG is our Postgres database package. So using Sequelize Auto, I've automated all the setup of our models. So if we look in models, we can take a look at characters as an example. You can see the interface with all our character attributes, the primary key, the model class, the initialization of the model, everything's been set up. Then I've added our first module, which is the characters module class. And inside the characters module, we have getQuery method. I've written out a query to get the hero. Then we do a little bit of formatting on our return data depending on if it was a single record or multiple records. And I'm also extending from a base module class just so I can take some of that clutter out of initializing our models for every class. I can quickly show the database client setup. This file handles our connection. It's a very standard Postgres DB running locally in Docker. The rest of the utils are the logger file and the config so we can set the log level. I've got rid of that handler.js, the hello world file, and I've created a new handler function. So this handler connects to the database. It then calls our characters module, the getQuery method, gets the data and returns it. And lastly, in our serverless YAML file, I've added the plugins for TypeScript and running serverless offline. And you'll see it's hooked up to the new handler and the path is set to /query. So let's do a quick Postman test and see if it's up and running. So I've set up a collection with our first endpoint. Because we'll use the same endpoint throughout this concept project, just like GraphQL does, I've set it up as a reusable environment variable. You'll notice I've set the method to post, and we'll discuss why a little bit later. So let's run our first query and see what we get. We have a successful return of our single hero, which includes all the heroes' associated data. Great, so our setup's complete. Let's start our exploration of GraphQL's capabilities and let's see if we really do need GraphQL. So as mentioned in the intro, this is a document we'll be using for our exploration into querying using GraphQL, with the goal of seeing how hard it would be to replicate what's offered by GraphQL without actually using GraphQL. So from the top, let's see what they say about the motivations for using GraphQL for our queries. At its simplest, GraphQL is about asking for specific fields on objects. So this is actually a good starting point, and this is always the first thing I've heard people jump to when they're new to GraphQL and they want to justify its usage. Isn't it wonderful? It stops all that overfetching of data. And it goes on to talk about the fact that the query has the same shape as the result and that you always get back what you expect. Right, so do we really need GraphQL to ask for specific fields and objects and get back data in a specific shape? My answer to this would be no. If all you want to do is get back specific fields, then there's no reason why your good old REST API can't be made to do this. You could just send through a query string with a list of fields. But if we take it that step further and specify the shape of the results, that's where you'll need to start breaking rules. And that's exactly what we're going to do. We're going to break some rules and make our API just a little less RESTful. To do what GraphQL is doing, you're going to need to start making post calls instead of get calls to fetch data. If you send your request to GraphQL Apollo server over HTTP, you would be doing queries using POST. So horror of all horrors, this is what we're going to be doing. We're going to be making queries using POST. So ultimately, this is what we're expecting the query to look like. Yes, the GraphQL body is a little bit cleaner, but our custom query will have pretty much the same structure, and maybe it's more descriptive because it's easy to see that colds refers to the columns we want to retrieve. So what I'm going to do again is pause here and see how I can manipulate our base setup to replicate GraphQL's abilities for asking for specific fields and objects and getting back data in a specific shape. Right, let me walk you through the changes. So in order to help with the rest of the project, I've started building out some base functionality. So the first thing we need to do is to be able to call the correct module dynamically. So our dynamic class does that for us. We import all the modules. Then we create a map of the set module names linked to the parameter names that our API can use. Then our constructor takes a class name, and for now we can reference it by hero, human, or characters, and that's used to map it to its module. Then we can instantiate our new class and pass in any options. Next, I added a query builder. That's where all the heavy lifting is done. So the first three methods take care of the data cleanup. So they make sure that if columns are requested that don't exist in the model, they're removed from the query. Then the most important method here is our find method. This builds out the query by piecing together first our columns and then a filter. Technically, we didn't need a filter for our column fetching step. So this only had to be done now because hero, as we said before, is a bit of a hack where we take the characters and just pull out a single hero. So we needed to add that filter in now just to make that piece of functionality work. Then the changes to the characters modules were we needed to specify the allowed columns as mentioned in the query builder. So all our get query has to do now is run the find method and we should get the characters we need. Then we added a heroes module, and as mentioned that was a hack because it's really just a specific character, and this is where we use that filter parameter to get the single hero record. Then we just call the characters get query method. There were quite a few extra interfaces. Query Builder has a few interfaces which we'll continue to build on later, and the module interface allows us to enforce that all our modules have the get query method. Then finally in our handler we made a few changes here. We now get the body parameters. We get the data by calling our dynamic class, passing the module in each time. So already we should be able to fetch multiple modules. And then at the end, you'll see that if there wasn't a body, we just return a ping response. And if there is, then the keys are our models, which are mapped to our modules in a dynamic class. We call the get query of the module we determined we need to use, and we get the response data. So if we requested hero as one of our parameters, hero will be one of our keys. We loop through those keys, we get the data, which then goes to our dynamic class to get the correct module. In the dynamic class, we have our map of hero to hero's module, which lets our constructor instantiate and return the hero's module back to our handler. Now our handler can call the hero's module getQuery method and get the data and return it. So let's go test it out. Well, the proof is in the pudding, so here we go. We'll see a side-by-side comparison. GraphQL was expecting a hero, and we only wanted to return the name column. Our query is exactly the same, just in JSON format. So there we have it, data hero name, and our result is identical, data hero name. We have some tests set up as well, because at each step we'll need to make sure we haven't broken anything in the previous steps. Then, as I said before, here is really just a hack to pull out a single character, like the documentation example is doing. So let's see a more real-world example where we request characters and get back an array of characters, not just a single object. We requested characters, we got back a characters parameter, an array of all the characters with just their name, and our tests are passing successfully. There's just one more additional thing I want to test. Remember, we added an array of allowed columns. Let's just check that we don't break our application or get any unusual results by requesting columns that don't exist or aren't allowed. So in this test, we request a column called test. Let's see what happens. Perfect. Our result only returns the legitimate columns. It stripped out the test column and ignored it. I'm always going to validate our schema in our Postman tests, as that was a big part of the requirements of this build. But while we're at it, why don't we check if we can fetch multiple models at the same time? We need a few more code changes to implement that, so let me make those and I'll catch you in the code segment again. Right, so here we are. I've added a new episodes class. It has the allowed column set, our required getQuery method, and it returns the results of our query builder find method. And we mustn't forget to add the new models to our dynamic class in the classes and the class map. And that's all done, so let's test. So I will now request heroes and episodes at the same time. We get back our hero with the requested columns as well as an array of all the episodes. Of course, we continue to build out our tests, making sure we always get back the schema we requested. Great, so fetching multiple models is a breeze, and this plays back into the next point in the documentation. So the documentation goes on to say, fields can also refer to objects. In that case, you can make a sub-selection of their fields for that object. GraphQL queries can traverse related objects and their fields, letting clients fetch lots of related data in one request, instead of making several round trips as one would need in a classic REST architecture. So again, here we go with the classic REST architecture. So again, it boils down to being prepared to bend the rules a bit, which, as you may guess, is exactly what we intend to continue doing. So do we really need GraphQL to fetch related data in one request? Once again, my answer to this is going to be no. There's no reason why we should need to make multiple calls if we can get the function at the other end of our endpoint to do the heavy lifting for us and return what we requested in a single request. So this is what our query would look like. Again, the GraphQL request body is a bit cleaner, but our custom query still has pretty much the same structure. So what I'm going to do again is pause here and see how I can extend our current setup to fetch related data. So let's see what changed. Adding relationships was quite a bit of work. So the first thing we did on the characters module was add related models, and characters has relationships with friends and episodes. The next big chunk we needed to add was how to fetch friends. So in our case, it's not so simple because our database structure requires a join. So I needed to add in some extra join data. The join as lets us tell us which table alias we're using. Then we have join attributes, so we can tell it which joined columns to fetch. Then what I'm doing is for each row of our original data we returned, we do a lookup on the related data. So in this case, our friends. We run these asynchronously with our promise all. And once we get all our data back, we'll need to merge it into our original data. Then on our getQuery method, we had to check our parameters to see if friends were requested. One problem with the related data is that we can't do the related data lookup if we don't have the original data's ID or primary key. So that means we need to add the ID column into the query even if the user didn't request it. So that params ID call added is so that we know we need to strip it out at the end. The params related was my attempt to make this more dynamic, so we have a bit more flexibility in how we join the data. Like our fetch friends method, now the query builder can take care of fetching the extra data, merging it in, removing the extra ID. We just need to tell it which class and method to use for the data fetching. So next I'll show you how this ties up in the query builder. So we discussed removing the ID column if we needed to add it for the purpose of a join, and remove ID col is a helper for removing that ID column at the end. The next big chunk I added was the extra lookup. This is the method that checks if there was any related data required, and if so, for each related model it dynamically calls the class and method we specified, gets the extra data, and merges it back into the original data. If the ID column was added, then at the end we remove it again. In our find method, the main change was to check for our new query params join property. The first part pushes any additional joined columns into our attributes, and include is where we specify the table alias. And for now, we don't need to pass in any additional attributes. Then at the end of our find method, after we fetch the main data, we run our extra lookup method, and our data should now include any related data like our friends that was required. And we don't need to discuss all the changes in the query builder interface, but I've added some new parameters: join, related, ID call added, and for related data, we require models, class name, and the method name. Let's go test it out. So here's our side-by-side comparison. On the left, GraphQL requests the hero's name and all the friends. We're going to do exactly that in Postman. Our response is identical. We have fetched our hero, just returning the hero's name. We also fetch join data, which is all the linked friends. As always, we have our test set up, and this time verifying that the friends array is always returned. But as I said before, the hero is a very contrived example with just a single object. We would most likely be querying an array of data, and that would look like this. The payload is exactly the same shape. What we get returned now is multiple characters. Each one of them has an array of friends. And we're going to make sure we have tests for that as well. At this point, I'm going to take a little detour here and take a look at GraphQL's pagination. First on the list is slicing, and they say, quickly though we realize that there are additional behaviors a client might want. A client might want to be able to specify how many friends they want to fetch. Maybe they only want the first two. They give an example of how GraphQL would fetch the first two friends. It goes on in pagination edges to talk about the ways we could do paginations, and there are a few different ways. We can go the offset route or the cursor route. But do we really need GraphQL to implement pagination functionality like limits and offsets? You probably guessed the answer, no. Most APIs come with pagination. What's unique here is that we can have a limit on a subarray of data, which is a nice feature. But there's no reason why we can't implement that. And the way we're going to implement it in a JSON format is just to add more parameters. So we have a new limit, offset, and order by parameters. I'm also going to add order by into the task of this chunk of code because otherwise our results may always be different and we won't really see the offset very easily. Order by is just a simple string for now, but we could just as easily have an array if we wanted to order by multiple columns. So let's break here. I'll see if I can get limits offsets up and running, and I'll catch you in the code segment once I'm done. Right, let's see how much work was involved to add in some pagination functionality. So if we look at the query builder interface, you will see that now we have extra parameters limit, offset, and order by. Our join also needed the extra order by and filter parameters. On our characters module in fetch friends, I've just added an order by to that join. I've also added an order by date created to our getQuery method if no other order is specified. So very small tweaks there. And lastly, on our query builder in our find method, we now have the order by added. If we don't have a join, that's very straightforward. There was some extra table mapping for the aliases I had to do if we had a join. And then offset and limit are very straightforward to add in, so overall not a very big change. And that's it, so let's see it in action. Back to Postman. So in the first example about slicing, we first wanted to just test limit on the number of friends to return. The documentation have limited friends to 2, so let's do the same. They don't show the results in the example, but you see our result is exactly the same format as before, only now they're just 2 friends, whereas before it returned 3 friends. So our limit is working. We put some extra tests in place. Now we're also making sure that only 2 friends are returned. The next test I've set up is where we have a limit on both the characters as well as our related friends data. And this works as well. We only have 2 characters being returned, and for each one only 2 friends are returned. We have a test on this one to make sure only 2 characters are returned. Now let's test our offset. Same payload, but now I've added offset and order by. And so now 2 different friends are returned because they've ordered them by name and skipped the first friend. We can verify that again by just taking out the offsets and note the shift in characters. I've also set it up that if there's just a single result, we end up with an object rather than an array of objects. You can decide if that's the desired outcome for your API. Let's get back to our original state, so our tests run as expected, because we were testing for a specific number of friends and making sure that Luke is the last character. A bit further in the pagination docs, they talk about getting additional data like total count. I'm not implementing every piece of GraphQL functionality in this prototype, but total count is useful for our pagination. So do we really need GraphQL for getting total counts? Well, of course not. Again, what's unique here is that there's no reason why we can't get a total count for both our primary data and our related data. You won't see that too often in your average REST API. The way we're going to implement it in a JSON format is just one more additional parameter called total count, surprise, surprise. Off I go again to implement. See you on the flip side. So what changes did we need to make this time? So if we look at the query builder interface, you will see that now we have an extra parameter total count, so small change there. And on our query builder, in find at the bottom, we have now split out find all if we don't need the count, and we use the ORM's method find and count all if we need to get the count. And then after our extra lookup, we have a slightly different return. So now if we want the count, we have the total count added to the return object. So all in all, a small change. Let's test it out. So here's our GraphQL comparison, requesting the total count on friends. And there is our total count parameter. When we run it, there's our total count inside our friends object. Now if you remember from the previous example, friends used to be an array, but now it's an object, because we needed to embed our total count into it while still keeping the friends data as an array. Hence the extra attribute called data inside the friends object. Anyway, now it's clear that while we only have 2 friends being returned, we actually have 3 friends in total. So there's some more tests, only 2 friends are returned, and the friends total count is 3. Let's take that one step further, make sure that total count reflects correctly whether it's in the main characters object or within the friends. The result correctly shows that we have 5 characters when we only return 2, and each of your characters has 3 friends while we only return 2. And as usual, there's some more tests to be set up for our future testing. So leaving pagination, going back to the GraphQL queries document. Next on the list is arguments. So the documentation goes on to say, if the only thing we could do was traverse objects in their fields, GraphQL would already be a very useful language for data fetching. But when you add the ability to pass arguments to fields, things get much more interesting. Well, I'm not sure it's much more interesting, but yes, it is a nice capability to have. It goes on to say, in a system like REST, you can only pass a single set of arguments, the query parameters and URL segments in your request. But in GraphQL, every field and nested object can get its own set of arguments, making GraphQL a complete replacement for making multiple API fetches. You can even pass arguments into scalar fields, to implement data transformations once on the server instead of on every client separately. So, do we really need GraphQL to pass arguments to fields? Well, no. Once again, if we're prepared to bend the rules a bit, this is not very difficult to implement at all. The way we'll implement it is with a new filter parameter. This is a rather rudimentary way of doing it because we don't have much flexibility. We're only filtering if the key equals the value, so we won't be able to pass in greater or less than, etc. But let's just follow through with this example as is. We already have a filter in place, so the only complexity we have to solve right now is filters on a relational record. Off I go again to implement. See you on the flip side. So there was a bit more work needed to do on our joins for this change. So if we look at the characters class, you'll see we added the join filter method. For now we only have a join on episode, but we can add more later. And here we describe the join as we've done before. We also added a filter, which filters by the episode name. And then because we're querying on the episode join table, we need to remove the filter from the main query. Then we can return our altered parameters. Then in our get query, we check to see if we have a filter, and if so, we pass the logic through to our new join filter method, just as we discussed above. Then in our query builder find method, we needed to add more logic to our join, so our include parameter now has a where parameter added. So our where is associated to our joined model and not the main model. Right, let's test. We're going to follow again with the documentations example. They're looking for an ID of 1000. Our records have UUIDs. Once we run the query, we get back the identical payload which should be expected. There was nothing complicated here, no relational join. Let's take a quick look at our test, which validates that that particular UUID belongs to Luke Skywalker. So let's try something a bit more complex and filter on a join table, which is episodes. So here we get the hero where the episode was Empire. A little coincidental, but once again Luke Skywalker pops up. I'm still keeping our tests going. But I know you want to see what happened if I change the episode. So here we go, we'll try Jedi as the episode. And thank goodness it didn't return Luke again, otherwise you'd think I'd just hard-coded the responses in. The documentation then goes on to talk about arguments can be of many different types. In the above example, we have used an enumeration type which represents one of a finite set of options, in this case units of length, meter, foot. GraphQL comes with a default set of types, but a GraphQL server can also declare its own custom types as long as they can be serialized into your transport format. And this is not about implementing every little feature of GraphQL, so if you want to be able to change between meters and feet, you can create some extra logic for that. I'm still not sure this is a strong use case for changing to GraphQL, and I'm not going to build this in. So we'll move on to aliases. And the documentation says, if you have a sharp eye, you may have noticed that since the results object fields match the name of the field in the query but don't include arguments, you can't directly query for the same field with different arguments. That's why you need aliases. They let you rename the result of a field to anything you want. In the above example, the two hero fields would have conflicted, but since we can alias them to different names, we can get both results in one request. So, do we really need GraphQL to use aliases? I'm sure you're getting the answer to this by now. As before, with a little effort, anything is possible, so no, we don't need GraphQL to use aliases. So let's see how much effort it is to add aliases. So the idea is that you should be able to call the object we want to get back anything we like. We just need to tell it which model it's referring to. We could follow the GraphQL format a bit closer, and we'd have to break the attribute with a colon, but for speed I may set it up by creating an additional using parameter, and that will map it to the model. I'll be back with the code solution. So let's start with the query builder interface. You will see we now have an extra parameter using, and the main change happens in our handler. We pass the alias into our getData, and if an alias is passed in, then the class we use is the alias we specified. Then at the bottom, you will see that the parameter we're using to specify the alias is called using. And now we should be able to call our argument anything we like, provided we also supply the using parameter. So here's our side-by-side comparison. GraphQL is asking for two heroes, one where the episode is Empire and one where the episode is Jedi. And we want the response to return our data by the aliases. So on our postman side, it's a bit more verbose, but we can use our new aliases. And for each one, we tell it which model to use. And we're filtering by the episode. The response is just like the GraphQL response. I just asked for the additional height, which is why we got back a little bit more data. And as always, we have our tests, and we're making sure to get back our correctly aliased objects. Lastly, let's run all our tests to make sure all our functionality still works and nothing we've written at any point has broken something else. Wonderful, all in the green. So this was a very rough and quick project. I could have spent way more time optimizing it, especially getting that related data working better. I had to do extra work to follow through with examples in the docs, which wasn't optimal for the project. But I think at the end of the day, it was an interesting exploration of GraphQL's query functionality. It was an interesting thought experiment in how we can make our RESTful APIs more flexible. So in conclusion, let me make some observations on what it took to add GraphQL query functionality into our APIs. So requesting specific fields on objects and getting data back in a specific shape. This was actually quite simple. What took time on this was that we did some setup on dynamically including our classes and setting up our query builder. We had to build both the character and the hero, of which the hero was technically only to follow through with the documentation examples. And we had to add the filter in here as well. So we ended up doing more than was expected of this step. Interestingly, adding this step already allowed us to fetch data from multiple models. Remember, we were already able to get our hero data and completely unrelated episodes at the same time. So my conclusion would be that this is completely worthwhile building into your APIs. If you're worried about over and under fetching, this is not a big deal to build into existing systems, and you probably haven't reached the point where you need help from GraphQL. Then fetching related data in a single request. Honestly, this part was a pain. I had to wrestle with the ORM and would still have to do quite a bit more work for it to be completely foolproof. We had to do lots of asynchronous calls in order to get the data back in the shape we wanted. I guess it would have been possible to have a join query, but that would have then required even more work to reshape the data afterwards. There are probably easier and better ways of doing this, but I didn't have time in this short exploration to come up with a solution that I would have been happy putting into production. On pagination and total count, this is straightforward. Most frameworks have pagination capabilities already built in. However, as I said in this section, what I can't say I've come across is being able to limit or paginate a subset of related data, and that actually wasn't that difficult to do. I think on this one you could still get away without needing GraphQL. However, honestly, I probably wouldn't go as far as paginating subsets of data. Then on passing arguments to fields, given the time, I think I could have added much more flexibility into our filter. I would have liked to extend this, so instead of just passing in an ID and a value, you could pass in the operator, so not equal or greater and less than, etc. Adding a filter to one's API is actually quite easy to do, and in hindsight, given the time, I would do it a little bit differently to the way I did in the example, so I didn't have to write so much custom code for the join. I think this would be completely worthwhile to build into your APIs, and not a strong motivator to move to GraphQL. Using aliases, being able to pull out multiple records individually and name them anything you want is a very nice feature. And the bonus was it was very quick to add. Definitely worthwhile considering adding to your existing API. Not sure if this feature is a strong motivation for GraphQL either. Then final thoughts and observations. As a final conclusion, as I said in the beginning, it's a matter of using the right tool for the job. Using an ORM definitely had its advantages in a project like this, with its interfaces, typings, and relationships, and it would be interesting to see how much we can build on the ORM's capabilities to better mimic what GraphQL does. There's room to improve our existing APIs with more flexibility, but I wouldn't go the route of a single endpoint with the implications of how to document your API, because you wouldn't be able to use open API specifications, down to the authorizations, the rate limiting, the caching, and more. I think they would just be taking it too far. Anyway, happy coding. Cheers.